Okay, so now let's do a quick summary of codes, standards, and ethics altogether because they kind of feed into each other. So these three components are what separate reliable engineering from risky improvisation. And improvisation is doing things from the top of my head, which means randomly without relying on any certain standard. Responsible engineers do not do that, right? Like good engineers don't do things out of their head. It is legally safer for themselves, right? If something happens, you followed the code. It's the code's problem, not you. And also, it is better for society overall because all these codes and standards had a lot of research and a lot of work put into them, right? So it is better to follow them instead of improvising. So as civil engineers, our work directly affects the safety, well-being, and daily lives of millions of people. The bridges we design, the water systems we manage, the buildings we certify and construct, they all must be safe, durable, efficient, and of course, done ethically. That's why we have these codes, standards, and the ethical foundations for our discipline, because it is easy to go rogue. It's easy to do something wrong. So we need to have all these guidelines to make sure it is consistent all around the planet. Okay. So why these matter? Civil engineering systems are high impact and high demand, right? Humanity cannot live without civil infrastructure, without shelter, without homes. It is the number one industry in the world. It's the industry that keeps on going, and humanity will always need it. There's a saying that there are two industries that humanity will never stop needing, and that would be civil engineering and homes. People need to live. And food, people need to eat. So these two. So civil engineering systems are high impact. They can save lives or put them at risk, right? So these codes and safety standards ensure that we're following the best practices and ethical guides. And we do not put ourselves in gray areas. We're always, in the white as much as possible. Our responsibility does not end when a project meets the minimum legal requirement. It continues through the life of the system, especially when real life challenges emerge. Now, what is the difference between codes and standards? Codes are formal, legal documents enforced, and this is like a big underline, enforced by law. They define the minimum safety requirements. For example, ACI 318. ACI 318 has grown, right? It's a standard that has grown to become something illegal because it is that good. It is that well designed. So most countries follow it or follow the British or Euro code, but, it has reached that status. It governs the structural use of concrete, of reinforced concrete, right? Standards, on the other hand, are consensus-based guidelines created by professional organizations. They represent the best practice, the highest level of recommendation, not legal mandates. They're not enforced by law. There is no penalty if you didn't follow them. This includes ASTM standards for materials, AASHTO specifications for highways, unless the local government says these are codes, you have to follow them, then they become legal. So there's always this twist. You can think of codes as the floor and standards as the blueprint for excellence. So ideally, when you want to design something, you want it compliant with both the code and the standard. If there's a distinction between them, you want it to be compliant with both. And usually, like 99% of the time, they're not contradictory. And the code will not go against the standard. It is almost always the case. The code is completed by the standard. Okay? So ideally, you want it compliant by both. And some of the most famous codes and standards for structural engineering, of course, ACI 318 for reinforced concrete. We have AISC and NC for steel, ASTM D2 487 for soil classification, AASHTO's Green Book, also amazing. Environmental standards, we have EPA and ISO 14000. Construction, we have OSHA. And I'm specifying OSHA because it is probably the number one safety code in the world. So that's how critical it is, and that's how important it is. Now, why do we need ethics? What is ethics and why do we need it? Now, ethics steps in when we have a situation that you open the code, you open the standard, and you don't have an answer to, right? That's where ethics come in. Ethics refer to the moral principles that govern an engineer's behavior, especially when no regulation tells you exactly what to do. When no regulation tells you exactly what to do. So ethical engineers think beyond profits, beyond deadlines, and ask the question, is it safe? Is it fair? Is it honest? Is it good? Is it reliable? All these things. And the most prominent code of ethics is the NSPE Code. And it has 6 main principles: hold paramount the safety of the public and the health and the welfare of the public, perform services only in your area of competence, don't talk about things that you don't know about, issue public statements only in a truthful and objective manner. So don't say something for the public, the people you meet on the street, that you're not 100% sure of, or they're not true, or trying to hide something. Act for each employer faithfully as trustees, as faithful agents. So do honest work. Avoid deceptive acts, hiding things, lying, etc. Conduct yourself honorably, as in be poised, well-mannered, well-behaved. No, don't be aggressive, rude, etc. These things, the proper conduct, which we all know of an engineer, that poise, that wisdom. So some ethical dilemmas in design. What if you suddenly had a cheaper material that meets the code, but it fails over time? So which NSPE canons you're breaking in this case? If your employer doesn't know, you're breaking the act for each employer as faithful agents or trustees. You say it fails faster over time. So the public does not know, usually thinks it will behave normally because they see, let's say it's a bridge, right? And they know bridges last for 70 years or 50 years. And suddenly in 50 years, this bridge is looking weird. And they think, oh, it's fine. This is just superficial, right? And the fast forward a couple of weeks later and the bridge fails and kills a lot of people. So you didn't prioritize the safety of the public just to save some money. So you also broke the first principle, which is the most critical principle of them all. So in this case, in this dilemma, these two were broken, right? Let's take another case. What if a planner is pressured to approve a project that harms a community by their employer, right? So the first principle applies. And what else? The sixth principle, they need to act honorably. Yes, they're being pressured, but they need to act honorably aside from the pressure, aside from the need for the job, and so on and so forth, and really do something about this problem and make sure the community is safe. The community is above their job. So you really need to read the situation, read the scenario, read the case study, and then identify which ethical principles, which canons apply the most, and therefore which ones are being broken and should be taken care of. So careful reading of these problems is always essential. So in the end, civil engineers must uphold both technical excellence and moral accountability, right? I will not get, for example, cheap steel because I know it was stolen, for example. Yeah, it's an extreme scenario, but you get my point. I mean, you need to always be mentally present and really understand the situation. If there's something suspicious, do something about it. Codes tell us what must be done technically. Standards guide us how to do it well, how to do it in an excellent fashion. And ethics remind us why we do it in the first place. First principle is to serve society and serve society well. So whether you're designing a skyscraper, reviewing a plan, speaking out against a flawed design or a project, your integrity should be your first tool, and then your knowledge and understanding. Okay. So this hopefully summarizes all the key ideas in codes and ethics. And hopefully you really get a good understanding and you are well prepared. Thank you.